Okay, so this is my video for Lab5. I'm just going to quickly show that I was able to get the Unity simulation working on my computer. You can hear my fan and how loud it is, so I'm just going to quickly show this and then exit out of the application. But this is what I ran for 2.5 hours to get my simulation log, tagging each animal with the circuit that I created. So that's shown now. I'm going to quickly just exit out of this and then we will show my circuit. So I'll do that now. We'll quit the application. Okay, so I'm going to exit to desktop, and then now I will just quickly show using that simulation. This is the actual circuit or the device that I tagged the elephants, the lions, and the zebras with. So I believe the requirements for this were to have an Arduino circuit and then a GPS and a vital sensors monitor and then 2 other sensors. So you can see that I decided to go with the GPS module, the humidity sensor, the temperature sensor, and then the vital sensor, and then just like an LED that would light up when data was being printed out. So you can see my code. It's essentially just in that loop running and printing out data. So that was what was happening. It was being printed out in the log during those 2.5 hours after I tagged the animals. So doing that, going in, tagging, I believe about a total of 20 or so animals resulted in what you see here, which is one of the simulation logs. So I think this is not the one. I think it's this one. So yeah, you can see here timestamp data for each unique individual animal. So it starts with this elephant, and for each animal it gives oxygen saturation, location, humidity, and temperature. So this giant log is what I used for my analysis to answer those 7 questions. So I can quickly now transition over to that. I showed the circuit and the simulation working. And now the last component of this is just the analysis and answering the questions with that data. So I used a Jupyter notebook. I took the data from its text format and I converted it into a data frame of about 70,000 or so records, where each record would be one of those individual timestamped events, taking in the animal type and the animal ID. So that's what I used for that. So now I'll just get into the questions themselves. I didn't use any code for that first question, is the zebra population healthy? Because I think in doing the following questions, you actually get a really good answer. So I said that given the analysis done and answering the questions that follow this, I can say that the zebra population appears to be relatively healthy. I'll just keep it at that because I go into basically the detail that I discussed in this paragraph. And the conclusion that I came to is revealed through doing the next 6 questions. So I'll just skip ahead to the next one, which is, do the zebras have enough room to move around? So I started off by saying that this is somewhat subjective, and I think that for any animal, obviously more room would be better, and there isn't like a set amount that they could have, but we can use some of the location data to figure this out. So my thought process was to see how much total available area there was to all of the animals, and then see how much of that area was explored by the zebras during that 2.5 hours that I let the simulation run. So the result was this sort of scatter plot showing unique locations occupied by the zebras. So this doesn't say how much time was spent at each location, just for each timestamp, if that location was seen, then it was plotted on this grid. And then the grid was discovered by taking all of the locations seen by all animals, and then like finding a minimum X value, a maximum X value, a max Y, and a min Y. So I thought that was a pretty good estimate to see how large the actual grid was. So using that information and then doing some math, you can see that only, according to this, about 2.75% of the total available unique positions were taken up, and I said that this does not account for the fact that some areas were not really explorable on the grid, such as the giant rock section in there, or maybe some other areas that the animals just didn't want to go to. It also doesn't take into account the fact that just because you're standing in a unique position, that doesn't mean that you're not sort of exploring the areas right next to you. I wouldn't say that you need to stand like a foot from where you are in order to technically explore that area, but you can see that there are still some chunks in the grid where the zebras did not occupy at all, such as this area you can see in my cursor, although they did get somewhat close. So I would say that 2.75 is not actually accurate as far as what they explored, but there are still some areas that they didn't explore. The only other point that I would discuss is that there appear to be like some sharp turns occurring at the boundary, which to me says that the zebras would probably move further out if they could, but then they're sort of inhibited by this boundary. Maybe they would want to continue running in a straight line, but they have to turn. So that's one thing, but I would say that for the purposes of our experimentation in general, the zebras had enough space, but if we had any control over it, then maybe we could make it slightly larger. Next, do you see any signs of poachers? So in my 2.5-hour simulation, I saw no signs of poachers. I basically determined this by saying that the heart rate never reached 0 of any animals. And you can see this distribution of the heart rates that we're seeing, so majority in that 41 to 60 range during the duration. I also said that this doesn't really tell us a whole lot. It just says that in this 2.5-hour simulation, we saw no poachers. It also means that no lions, for example, ate a zebra during that duration because no animals died. So in this simulation, there were no poachers, but that doesn't mean that there are none in the area. So next, I plotted the CDF of the movement speed of zebras. As far as what I observed, this is the graph, the resulting graph, but observation. So what this chart is telling us is that a small percentage of the zebra movements occur at low speed. So that's evident by this here where my cursor is. And then this giant spike that tells us that the majority of movements occur here at the speed of about 2. This probably represents the average grazing speed I maybe proposed. So then this gradual increase from 2 to 16, resulting in this cumulative probability of about 0.1 increase, just indicates that it's rare for the zebras to move at a higher speed. Maybe it's to run away from danger or predator, and that was somewhat rare according to the data in this 2.5-hour simulation. Next is, do zebras make friends? I created this heat map that basically showed the distance of zebras on average when their timestamps sort of matched up in a certain period. So whenever a timestamp was within 30 seconds, checking each zebra pair what the average distance was between them at that point. And I think it's pretty clear based on this that you can see some groups. So the bluer boxes just mean that the average distance was closer, and the red ones mean they're farther away. So like you can see this group here of these two zebra groups, or these two zebra unique zebras. This is sort of a group, and then this is sort of a group here. So clearly there's some friends, and I speculated that there's a group of 3 and then a group of 2 of my 5 unique zebras that were friends. So that's the conclusion I came to there. What locations do zebras tend to congregate at? So you can see here, this is the total amount of seconds spent in sections of the graph, and the axes are slightly off, so it doesn't align exactly to this here, what you see, but you can see there's a big blue chunk here indicating a lot of time was spent there by the zebras, and that roughly translates to right about this area here on the previous graph. So I said, what exactly is at this location? You can see on the map, I'm not sure if the axis aligns perfectly, but it appears that at least in this like vertical sliver of the map, that's probably indicating that the time that was spent there was because the zebras wanted to be near and around water. So that was my speculation there. That's my best guess. Are there any locations that zebras tend to avoid? This is kind of in the same line using the same charts. You can see I said that it's kind of hard to determine in such a small amount of time, 2.5-hour simulation. If there's a reason why the zebras aren't spending a lot of time in certain areas, rather than just variance, and they might be running around randomly and they just didn't get to a specific area. But for certain areas, I think you can deduce that there may be a reason. So I pulled up a similar chart for the time spent for lions, and you can see that this area roughly would translate to about this lower left-hand corner on this graph, and it's the same for the zebra graph. So you see they spend almost no time up in that top left corner, so that makes sense because they would not want to be with the lions because that's a predator of theirs. So that's my Lab 5, and those are my 7 questions.